Little bit about myself first. As you as you all know, my name is Samir. I have been working in networking domain for past 9.5 years. I have experience in a very different, in very different companies. I have worked in medical field. I have companies. I have worked with financial companies. I have worked with BPOs, servicing industries, and all those years of experience. I have worked on network implementations. I have worked on operational issues. I have been working in providing L level 2, level 3 support. I have been doing implementations for Cisco ACI, Cisco ACI routing switching, firewall, load balancers. So I have worked on all like very core network technologies and uh, today I'll be taking the Cisco ACI, the experience, the knowledge that I have. I will be sharing that with you. Uh, Now I would like from I would like someone if they can unmute yourself and give that introduction like a brief name, their company, what are they doing, the roles that they are doing, and why they have joined this ACI class. Like what is their goal in joining this ACI lecture. So if someone can unmute and give us all a brief introduction, that will be really great.
Hello, Samir. Actually, it's a pleasure to be with you here, and massive appreciation for this session. Okay, my name is Abdurrahman Khattab, and I am from Egypt. I have been working in network field since 6 years. Okay, I joined multiple companies as well as a network operation engineer, and currently as a network implementation engineer. Okay. Now I am working in Orange Business. Maybe it's familiar with you. As a network implementation engineer, our scope of work is implementing SD-WAN and Fortinet SD-WAN as well, and MPLS and Meraki and so on. Okay, and I am joining this session because I need to enhance my technical skills, especially in SI.
Great, great. Thank you so much, Abdul. Really
Thank
appreciate you sharing that information with us. Anyone else?
Hi, I don't know if you could hear me. My name is Ignacio Sanchez. I'm a network engineer, been an engineer for quite some time, but I would like to enhance my understanding of ACI. And I've taken a couple of classes here at Network Journey and I like the classes. So looking forward to what you're going to show us today.
Great, great. Appreciate that, Ignacio. You're welcome to the class. Thank you for sharing that. Anyone else?
Hello, everyone. Myself is Rahim, and I'm also the network and security engineer from last 15 years. Currently, I'm working for the banking sector. The reason to join this call, and this is, by the way, my first time to know about the ACI because it's nowadays market trend. So I would like to know some knowledge about this. Thank you.
Definitely, Rahim. We will go through ACI, very basics of ACI architecture, everything that you need to know to get started with the ACI. Really appreciate that introduction. Thank you so much. Anyone else wants to go there? After this, we will start the lecture. Okay, I suppose everyone is very excited to deep dive into Cisco ACI. So let's not keep you guys all waiting and let us start. So first, I'll start with Cisco is I understand we have like most of our of most of our audience right today is a network engineer. Is anyone here who is not from networking field, or who's from different domain and want to understand Cisco ACI? I just want to know so that I can adjust my terminologies to make it more easier for you to understand, and I don't miss all your expectation. Is there anyone? Okay, so I'll take it as that everyone is familiar with network terminologies. Everyone has some basic knowledge of network. Great. So let me hide this video. So can you all see my screen? I have shared a Microsoft whiteboard.
Yes, I believe you can see it.
Great. So let me start. So Cisco ACI. So someone has rightly said, I think it was Rahim, that Cisco ACI is right now the most like one of the trending data center technologies. In data center, because we all know data center is very core. Data center is like very critical in our infrastructure, in any network infrastructure, and this Cisco ACI. So first of all, what does a Cisco ACI stand for? So okay, one more thing. Today I don't have my pen and my digital pen, so I'll be using mouse and keyboard. So there will be a lot of drawings will be little bit not as expected. So apologies for that beforehand. So first of all, what is ACI? So ACI stands for Application Centric. ACI stands for Application Centric Infrastructure. Application Centric Infrastructure. Okay, so this is actually one of the product by Cisco. So right now, we all know we have seen Cisco routers, switches. Cisco has a lot of products they provide in networking domain. Even in storage domain, we have UCS servers, and we have in compute they have provided devices. In firewall, in security, we have firewalls. Even now they have with multiple acquisitions. They have got Splunk, they have got Thousand Eyes, we have Viptela, SD-WAN. So Cisco is a very big provider which is providing a lot of network solutions. And one of that product is Cisco ACI, which is for data center. Now, so ACI stands for application centric infrastructure. So I'll come to that. But why it is called just application centric infrastructure? Okay, because in network we just mostly focus on network devices that are connecting and making them communicate with each other. But right now, this product name is application centric, so that defines that the whole traffic, whole design, whole architecture is around this application. What are the application? It can be anything. It can be your web browser. It can be any user using even your apps. Let's say your Instagram, your Facebook, anything. These are our apps. So we have databases. We have a lot of storage devices, databases, processors in our data center. So we in a traditional network, we used to connect them directly in a network flow. But now we are more we the network is very aware of those applications. What are those applications? And we have built a network around that application. So we are catering specific to the application. So we are considering the factors that are important to that application. Now, before we deep dive into ACI, I would like to take you a little bit of how we came about the ACI. Why ACI? Okay, because this should be our first question as a network engineer. Why should I use an ACI? So I'll take you a little bit, in the traditional network design or traditional network terminology. When we talk about our network, so we had a three tier network, and the two and which is basically our core, our distributed layer, and our access layer. So let me draw that up. Okay, so we had this core, we had this distribution, and then okay, and we had this access layer switch. So this is like the three-tier architecture. This is called three-tier architecture. So this was our core, right? These are our distributed layer, or we can say aggregate layer, right? And this was our this was our access layer. So what used to happen is that all our devices, network device, any devices, let's say it's an IP phone, it's a user, everything, we connect to this access layer, right? And then we have this uplink. Maybe sometimes we have two uplinks for redundancy purpose. We do a port channel. We have then that goes to core, and from this core we we route that traffic out and other thing. So in a data center there are mainly two type of traffic, that is east to west and north to south. So this traffic is a north to south traffic. Okay, so how north to south? So let's just say this is direction, this is north, and this is south. So the traffic is let's say south to north. So this traffic is going from south to north, or let's say north to south. So this is a three-tier architecture. Now, uh, what happens in this scenario is that once we have multiple devices, we have, let's say, on our access layer, our network, our user base is increasing. It's the company is going through a good time and they are expanding. We have a lot of users, we have a lot of data. So this will eventually increase. There will be more uplinks here, there will be more access layer switches, everything will be there. There is a choke point. Do you identify where is the choke point? This is the choke point where we have the bandwidth, because even if we bundle this in a multiple port channel, the maximum we can go is about 16. So still we will have there will be challenges to expand this. And again, because this traffic is traveling two hops, there will be definitely more latency, bandwidth issues, a lot of things will be happening here. So coming now to our traditional network, I would like to know from you, what are the challenges uh, what are the challenges in our traditional network? Can someone give me some points on uh, challenges of a traditional network? We have a traditional network. I think we are working day in day out. So can someone give me some pointers here? Yeah, thank you. Yeah, one. Go ahead.
Packet drop issue.
Okay, packet drops. So packet drops means bandwidth utilization, right? Bandwidth
Yeah.
congestion, right? So we will
Second is
bandwidth.
network looping.
Great. That's a good point. We have second is network looping, right? So
Planetary loops as well.
Span and tree
net
blocking some of the active links.
correct. So network, I'll just say it's STP, right? Uh, okay. Other thing,
Port
management.
violation. Attack like
hmm Attack like
DDoS attack, snooping.
let's say security, right?
Right.
Because everything is permitted, like, because once we have, let's say we have connected uh, well, let's say we have multiple users in the same VLAN. There is basically very limited way we can control how they are communicating with each other, correct? They are talking to with each other without any restrictions, until unless we apply the ACLs. We can do that by, you can say that, we can do that by access list. But remember, a router is supposed to route the traffic. It is not built to perform the functions of a firewall. Then what will we need? We will need a firewall. We will need extra other devices to block the traffic or to control the traffic, right? So what that will cause? That will cause overhead expenses, right? Expenses, because we are adding additional devices. Expenses. Any other point?
Yeah, the other thing I mentioned is have your resources working, like more or less like because you have one active, one standby. One's
Right. Right. So we can say that we have redundant links which is not being used, and that is the wastage of resources, right? Redundant links and resources. I'll say just resources. Right. Okay. Now also we have CLI access. The management of net traditional. It takes. We also know that it takes a lot of time, a lot of energy. Let's say we have multiple switches. We have to go do a CLI. We have to type the commands. We have if anything goes wrong, we have to trace the path. Anything we have to do. It's a little bit hectic. If we compare. So I'll just say CLI access here
Yeah,
Yep.
something like
Yes.
and
the
upgrade.
routing lookup is needed on every hop.
Right, right. So
Yes.
uh,
One more thing, Samir, we can say as because I deal with legacy network and modern, which is the SDN or the SD-WAN. I noticed that in the legacy network, I face a complexity. It's very complex, okay, to troubleshoot. So overall, this is the most common thing about legacy network. Troubleshooting is very complex.
yes,
Yeah.
Abdul, that's yes, Abdul, that's a very valid point. So troubleshooting, right? Troubleshooting becomes very hectic. We know when our bosses are, everyone is looking at you when you are joining a bridge, P1, P2 bridge, and everyone is looking at network guy. Okay, he's going to resolve our issue, and we are thinking, okay, now I need to find which switch has gone wrong, right? So
Yeah,
that's a very,
correct. Yeah,
yeah,
I
that's a
have to
very
track every hope. Yeah,
that is a very that is a situation that no networking engineer want to be and not able to answer or find the solution, right? So we can say troubleshooting, and we also can say this all points to uh, centralized model. It's not a centralized, right? We need to go
yeah,
individually do everything, so not
yeah,
centralized.
yes,
Now coming
that's
to
correct.
right blacklist as allowed security, everything is permitted. Now what does Cisco ACI does? Cisco ACI, when it comes when the Cisco ACI was created by Cisco. So first of all, we need to understand that this Cisco ACI was also actually one of the acquisition by Cisco. The ACI, what we see today, it was a solution. It was a solution that was provided by a company, if I recall correct, INS or something. So they had this product. So Cisco acquired them. Okay, and then they heavily modified, heavily customized it as per the Cisco product. As we all know that Cisco has very good lineup of Nexus devices, core data center devices, everything data center. I remember time when it used to be Cisco. So what they did that they heavily customized it and gave a lot of good features. And we have a Cisco ACI, what we call as a Cisco ACI. So now coming to Cisco ACI. So what does Cisco ACI solves this problem? Cisco, okay, why? Oh, there it goes. Uh, I'm not sure why it's always going black, but yeah. So Cisco ACI. Now coming to Cisco ACI. So what are the advantages they had given us, right? In Cisco ACI, what happens is that it is using a three-tier architecture. Okay, we will call it sorry, it's using a clause topology. Yeah, my bad. Sorry, it's using a clause topology. It's not using a three-tier architecture. So it's called clause topology. It is using clause topology. Basically, it's a two-tier architecture. Okay, and I'll just remember this two-tier topology. I'll explain it to you much better what it is and how it is solving us issues. Then STPs. spanning tree protocol. Spanning tree protocol is basically it when it was created, it was like a blessing in disguise. It was for hey, there is a L2 loop. We have got you covered. STP, it is enabled on every Cisco switch. Okay, but what happened is that
There's no
just
STP in ACI.
create a scenario. Give me 1 second. Sorry, did you say something? Hello?
No, in ACI there is no STP issues. There's no STP is between the leaf and spine.
Yes, there is no STP, correct. So what happens in Cisco ACI is that there is no STP. So let me just give you a like brief about that. So this was our traditional network, right? Let's just say I have an engineer joining. There is a network engineer. He's happy that okay. I have I have a I have a server. Let's say this is a server. Okay, so I want the server to connect to let's say uh, to access layer to distribution layer devices, right? And then there is this uplink. Okay, now because I'll just remove this one. Okay, I just forget this one for now. So we have a server we have connected to this device, and this is, let's say, this is the access. This is like distribution layer, and this is our core layer. So what's happening here is that right now we can see this is not having redundancy, right? So we create a redundant path. So we bought this different distribution switch. We connected the second path and we connected here. So now what happens is that since this server, we are connecting to two different switches, the STPs is what spanning tree protocol kicks in, and it says no, you are not allowed to use you are not allowed. There's only one path in forwarding that can be allowed, and it blocks one path, right? So what happens is that immediately we don't have one path which we could have used for the STP. Now to resolve that issue, we have someone came up with the point that okay, what we can do is that we, instead of one link, we can group them in port channel. Yeah, you can do that, right? But there is also a limitation on port channel, how many port channel you can group together to create this. Okay, so still that does not resolve our purpose. Then Cisco came up with VSS. Okay, so they said, okay, what I need for redundancy, what I can do is I'll give you VSH virtual switch stacking, uh, and virtual switch system, and you what it will have is that we have one and two code switches, and they will basically provide a single control plane and management plane, everything. So so that there is you can utilize the links. Then this came into Nexus. When Nexus OS came, what they gave is that VPC, virtual port channel. This is the same thing that we have a active, we have a backup VPC, and let's say we have a server we have connected, and this both are both are there. The both links are there. The server does not know. It seems like seems the same is connected to it's connected to same switch, but in in principle, at a time only one link is active, one is there, because this is active, this is backup, right? So now what happened here is that Cisco ACI came. Now Cisco ACI, I will go through the clause topology right now. So in clause topology, it was developed by Charles Claus. Okay, it basically defines a two-tier architecture. Okay, and what does a two-tier architecture means? It is a collapsed distribution aggregation switch. Okay, distribution layer. So we had three layers, but now what we are going to do is we are having, let's say this is one spine, Okay, this is our, and in class in Fabric we are calling this spine. The cores are called spine. Okay, and let's say we have leaf here. Okay, these are leaves. There, let's say 2 3 leaves are there. So in two-tier architecture, these there will be this is the distributed, or this is the collapsed distribution aggregation layer. Okay, sorry, this is the distribution aggregation layer, and this is like, let's say, access. This is the access one. So our server, let's say a server is here, it is connected here. Okay, it's happily sitting here. So all the access, you see there are limited, there is like one hop has been reduced, and now this is all connected with each other, right? This is how it is connected. Each leaf is connected to each spine, right? So this is like a mesh, right? So each leaf, we call it as a leaf access. This is a leaf, and this each leaf is connected with each spine. So now, if let's say this server wants to talk to this server, it does not need to go through core and different cores and multiple hops. Everything is one hop away. How? Let's say this is leaf 1 and this is leaf 2. It comes to spine. It asks where is my destination. It says, oh, your destination is leaf 2. It comes directly to leaf 2. You see, so everything is just one hop away. This type of traffic is called east to west traffic. Okay, this is like the major part of data center traffic, east to west traffic, because in a data center we all know that there are multiple servers, database servers, backup servers. There is like web applications. So all those applications are talking to storage servers, backup database servers. They are like communicating with each other. There is a lot of traffic going on. We don't want to bog down that traffic using that tier 3 architecture. So more efficient way is the two-tier architecture, which is called a clause topology. And in Cisco ACI, we call it as as ACI Fabric, right? Now, why Fabric? You will say why it is called a Fabric, because uh, we could have called it two-tier architecture collapse, but why Fabric? Because see, this leaf 1 and leaf 2, like there are multiple, let's just say there are multiple leaf, they are all connected with each other, via spine. So this is like a cloth fabric. If you've seen a cloth fabric, if you imagine a cloth, all the threads are woven each together. They form a mesh. They are so strongly woven that they are, we are calling it a fabric. They are, each and every fabric is connected to each another. So that is the like main like terminology reason why it is called a fabric. Now coming,
Then there is Epic as well, right?
yes,
Which
I am coming to that point. Yes, give me few minutes. I'll explain you the epic, the architecture and everything. I will cover that in like next 10 to 15 minutes. Okay.
and even the spine to spine cannot be connected. Only connectivity
Yes.
will be like leaf to spine and epics. Then you have L3 out, then where your router or external devices will be connected.
Yes, Ishak. So I am coming to all those rules and regulations of how we should connect the traffic, how it should have, because see, a fabric basically anything runs on some rules, right? There are some guidelines. So those guidelines are necessary to keep that fabric running, just like how our society is working, how everything is working, the roads are working, we have traffic signal, everything, we follow a certain rule where it's irrespective of where you are. We know red light, green light, yellow light, right? So like that, we have certain rules in ACI, in any fabric. So once you have understood fabric, I'll come to that point. Now coming to security. So in a ACI fabric, everything is it's called a white model. Okay, whitelist model. So whitelist model. So basically, what does it mean is that any communication between any devices that are connected, even though if they are in the same VLAN, they will not be allowed until and unless we specifically allow them. Okay, and in ACI, the terminology we use for for ACL is called contracts. So once we get into lab and further classes, you'll be hearing a lot of contracts instead of ACLs. So in ACI we call them contracts. Contracts is just like ACL, but just a terminology used in ACI. So I totally understand today if you are very new to ACI, a lot of terminology will not make more of a logical impression. But believe me, once we are through this lecture, you will have a basic understanding of the terminology, why it is being used, and I'll try my best to make you understand in a simple language. Now, coming to
So,
contracts.
Samir, sorry for interruption. Can
No,
I
yeah,
ask
please go
you?
ahead. Yeah, go ahead, Abdul.
Yeah. So the communication between the leaves and spine. Actually, I have no idea about SI. It's first time to me, okay, but I just need to
Yes,
understand some. The
yes.
communication between spine and leaf
Okay.
is,
Mm-hmm.
yeah, I mean, sorry, the traffic is which is coming from the spine is
Yes,
distributed to the leaves in
yes.
sequence
Yes.
or
I
by
will.
rules, correct?
Yes, I will explain you the working of traffic.
Okay,
Just
it will be done
yeah,
later.
yeah.
Okay,
Just
okay.
I just if you give me 10 minutes, just I'll
Yeah,
complete
yeah,
these
sure, sure.
points, and then I will
Sure.
explain you the basics of how Cisco Fabric is working, how Leaf Spine is working, right?
Okay,
So
thank you.
yeah. I have your question noted. I have I think Ishak's question noted. I'll get back to them. So now coming to redundant link resources, right? So in Cisco ACI, in Cisco ACI, uh, we do not have STP, right? So since we do not have STP spanning tree protocol, all the ports are sending traffic. All the ports are active, right? In ACI Fabric, we are not blocking. We are not having any STP, and all the traffic is really routed traffic. Okay, how it is routed, why it is routed, I'll come to what protocols are running. So there is like a very brief, very detailed, deep technical thing on that, but I'll just tell you for now that since this is have not having STP, we have a lot of we have uh, a very good use of our resources, our links, and all the links are used properly, right? Now CLI access upgrade. So we have in ACI, we have called APIC. Okay, so what does APIC means? In any ACI fabric, we have a you can um, think of APIC as the brain of the Cisco fabric. Okay, because we need a brain to run the Cisco fabric. All right, so that brain is APIC. APIC stand for application policy infrastructure control, right? So what APIC is doing is that APIC is using APIC, we are going to configure the ACI fabric. Using APIC, we are going to manage how the devices that are connected on the leaf, switches, spine, the settings and everything. We are all going to do everything from the APIC. We are not going to touch anything on the actual device. We're not going to go into CLI. We could go for troubleshooting purpose and other thing, but we will be using APIC to manage everything, all our Cisco fabric, right? Now coming to troubleshooting, since we are having a single centralized control via APIC, we have a whole view, right? We have a you can say 30,000 feet view of the whole what is going in my network. APIC is actually monitoring that. APIC will give you uh, APIC will tell you what is wrong. It monitors. It gives you the score of your applications, your endpoints, and it tells you if there is an issue. Let's say a link has utilized heavily in your fabric. What we used to do that we used to trace the path where it is, the latency increasing and everything. But in APIC, we can note that with a GUI, just we are, with just a tab, that okay, my these switches or these links are right now heavily utilized. Is there any impact? I can correlate with that. Okay, yeah, this might be an issue. So we have a very good monitoring. We and even we can do auditing, because since we are not going on leaf and spine, we are doing everything from APIC. And in general, when we are in industry, working in industry production environment, you will be making all the changes, everything from the APIC. So the APIC will be everything. So we can audit logs who have made changes. Or we can check what changes are made. If any change made caused an impact, you can also come to know about that, right? So we have a good monitoring due to APIC. Now coming to your question, let me share 1 second. Okay. So yeah, so now I'll show you the ACI fabric, and I will take you through all that ACI fabric, right? Okay, so this is our ACI fabric. Okay, this is called ACI fabric. Now we have the spines. If you remember, I have told you this is a two-tier architecture. This is the spine, one layer, and this is leaf switches. That's it. And each and every leaf is connected to each and every spine. Now, what happens in ACI, in Cisco ACI? There is a rule that we do not connect any cabling, any cables. We do not connect anything from spine to spine or from leaf to leaf. We cannot connect. That is not allowed, right? Because this is if we connect this, it will cause a lot of problem. So in Cisco ACI, there is a protocol called MCP. Okay, this is a protocol called MCP, which is full form for misconfiguration protocol. Okay, so Cisco ACI is very smart enough. He knows that you have misconfigured something, and what happens is here the APICs are the brain. So APICs will know all the time what is happening in its network. It will always know what is happening in the network. Okay, these APICs, they will know what is happening in the network. So once it detects any link connected to your any link connected between spine or between leaf, it will immediately shut it down. It will not allow that traffic. And this MCP protocol is basically used by APICs. This is the protocol running in the background. So that answers your question. I think Ishak has asked that it's not using any there's no connection. So this is a very
Yes.
important rule in leaf switch and spine switch. Even when you are actually implementing or actually implementing a switch or spine, even if you by mistake connects a cable, it will not come up. It's not a best. It is not like not recommended. But if you do, you need not worry that you will create a loop or anything, because as I told you, there's no STP. But if any other issues would be there, this is already being covered. Now the second rule, this is like the first rule, that no connection, no interconnection between spine and leaf. Now the second rule is that all the endpoints, everything will connect on these leaves. Okay, everything, you name it, everything. You have an APIC server, it connects to leaf switches. You have a firewall, it connects to it connect to leaf switches. You have let's say you have you have a server, you have database server, DB server, that also connects to leaf switches. Everything
Even
connects to leaf
routers.
switches. Yes,
Routers.
routers, everything, name it, everything. So I'm saying everything. This is a basic rule. Everything will be connected to the leaf switches. Okay. You cannot connect anything on the spine. Spines will only be responsible for forwarding traffic between the leaves. So they will just connect to leaves, and we are not going to give them additional responsibility. So this is like the second very fundamental rule, very important rule of Cisco ACI fabric. Now coming I'll just explain you a little bit more about APIC server first, because I think you have a lot of question about APIC server, and we should have, because this is like the brain, like this is the brain of Cisco Fabric. Now, before that,
Amir, sorry, can I ask something?
yes, Abdul, please go ahead.
So EPIC, can we say the EPIC is the controller of our ACI?
Yes, that is the correct statement.
And it's similar to, for example, for the vManage in SD-WAN?
Yes, you're right.
Oh, okay,
So
thank you.
yes, so this is a SDN solution by Cisco, and you are right, vManage and this APIC, this is the same thing, right? They're just for control part. Now, yeah, so yeah, before that, I would like to first yeah, okay, let me just complete the APIC. I'll explain what the APIC is. So in this APIC is basically the brain of the Cisco Cisco ACI Fabric, right? Whatever configuration you want to do, you go to Cisco, is you log into APIC. You want to check something, you want to monitor something, you go to APIC. You want to like you want to upgrade a firmware, you want to upgrade devices, like in the Cisco like ACI Fabric, whether it's spine or whether it's leaf, you go to APIC. So for everything, we need to go to APIC. Now there is this another rule. I know there are, I know there are a lot of rules in Cisco ACI, but yeah, you will, once you get to know them, you'll know these are like why they are there. So the third rule is that in any ACI fabric, we should have minimum 3 nodes for nodes of APIC. Okay. So in any ACI fabric, so let's say in your company you are spinning up a ACI fabric, so you will need minimum 3 APIC servers. Okay, why not 1? Why not 2? Why 3? That will come to your mind, right? So why 3? Like um, when we are going to do the lab, you can see that we just when I'm going to show you the lab, we just have one APIC. So that time it is working, right? But in lab and R&D, we can use like one APIC. That is all fine. But in production, we need to have minimum 3 APIC. Okay. Now, what happens is that all the configuration, whatever you configure, whatever you do the configuration, everything will be stored on this APIC as a shard. Okay, as as a data that is called shard. So any configuration, basically this is the terminology called shard. What it means that, let's say you have created a configuration. Let's just say you have created a interface
Sorry,
policy. Go ahead.
that spelling is not quite clear. Can you drop it on the chat, please?
Sorry,
Shared,
what is question?
shared, I think. Or shared.
Oh, shard.
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 Yeah. Okay. Yeah. I'll just use the
It is shard. SHARD.
Yes, shard. So what is a shard? Shard is nothing but that data, that configuration. It is called shard in ACI Fabric language. Okay. Now what happens is that when we are doing any configuration, okay, at any given time, out of these 3 servers, one will be the primary one. Okay, one will have one we will be using to log in, and it will have everything. So these two will necessarily be like act like a backup. So they will act like a backup, they will be there, and this information of but whenever you are making let's say we are saving a configuration, you are doing a write, so that information, let's say we are calling it shard, it will be saved on this APIC server, but also it will be saved on this server 2 and server 3 also. Why that is because for the redundancy, for the redundancy of the APIC of the Cisco ACI Fabric. Let's say your one is APIC server goes down, there should not be an impact, right? You have the shard, you have that information. Where is okay?
Why can't we go with the 2 for why only it is with even numbers?
Yes,
Split.
that's a very good question. Let me explain that to you a little bit more.
Different condition codes.
shard. Okay, so what happens is that it creates a shard, and it saves that to server 2 and server 3. Okay, what happens is that if one of these goes down, okay, for redundancy purpose, these two will be up, but you will get an error like, okay, that the APIC is down, do something. So definitely if an APIC goes down, that's a priority, like high priority ticket. You need to see what happened. You need to bring that the APIC and everything. And this uh, let me give you one slide which will explain more better why three shards. Okay, let me open a new sharp whiteboard. Okay. Okay, let me know once you see. Okay. So you see then this APIC 1, APIC 2, APIC 3. So we have a data set 1, 2, 3 copy. Okay. Now we have made a changes. One copy is active on this APIC 1, and there will be a backup copy saved on the other twos, right? Once if it goes down, we still have the APIC 2 will take over, and we have all the data set 1, 2, 3 copies here. Now this APIC 2, this will become active, right? Because we have the data here, so this will become active, and APIC 3, it will stay like that. What happens if APIC 2 fails? If the APIC 2 fails, then our ACI fabric, what happens is that you will not be able to make any changes. You will have the necessary a read-only access. You will be able to read all the information and everything. You'll be able to see. But if let's say there is an incident and there is an outage, and you want to make a change in the ACI fabric, you'll not be able to do that. So ACI will not allow you until and unless it has minimum 2, and it will alert you for 3. So we need to have the 3. This is like the architecture the ACI fabric has set up. And in a pod, you can have maximum of 5 APIC controller. Okay, it depends upon the size of the APIC, the size of the leaves that you have. Let's say, for example, 3 APIC controllers can handle a traffic like 80 leaves. 80 leaf. So if let's say you have 80 leaves in your data center, right? So you can have, what you can have is a minimum of 3 APIC server. They will be able to handle around 80 leaf. But let's say you have something more than 80 leaf. So up to 200 leaf, of five APIC configuration, five APIC configuration will be required. So 5 APIC server will be there. So then you can extend or scale your leaf switches to up to 200. So 200 is a very big number, but if let's say you have a very big data center, that this will be the solution that will be given by Cisco. Coming to my original Cisco ACI. Okay, now, so okay, so what happens here is that let me just create a new one. Okay, so now what are the devices, now I have been talking about Cisco Fabric and everything, right? But what are the actual Cisco devices? What are the Cisco models? What are the Cisco devices that we are using in spine and leaf switches? Definitely these are Cisco Nexus devices. Okay.
And different fabrics.
Yes, but these are specialized Cisco Nexus ACI devices. When I
Sorry
say,
to interrupt.
yeah, please go ahead.
Sorry.
Sure,
Yeah,
yeah,
so you mean to say like it should be the concept of 1357 in the epics?
not 1357. I said 3 and 5. Maximum you can have
3 and
5.
5, yeah.
Minimum is
Yeah.
3. Yes, minimum is 3. You
But
need to have 3.
yeah, but if we can have a 4, like it is acting like an active shard backup, whatever. So why can't we have with the 4?
Yeah,
Or 4 epics?
you can deploy 4 APIC. That is not a problem at all. You can do 4 APIC, but minimum you need to, as when you are when you are implementing a Cisco Fabric, you need the minimum APIC you need to have is 3 up to 80 leaves. So you will need to have 3 APIC servers. If you want to do 4, that's all right. You can do that. The fourth will also have the configuration backup of the data sets, and it will, there is like more details. I'll in the coming lectures I will be able to provide you more details, how they are working, what happens if someone fails and everything. If it's a 4, why the fourth one? But from Cisco ACI Fabric standpoint, you need minimum 3. You can deploy 4 if you want to. If you have more resources, well and good, you can do that. But minimum 3 is required, which you have to do. Okay,
But
I hope I answered that.
I believe Cisco recommendation is to use odd numbers, right? 3, 5, 7 for split brain issues.
Yes, exactly. This is what the concept actually.
Oh, yes, you are right. So 3, 5, you're right. I was thinking something else. So you're right. Let me correct myself. You are right. 3, 5 in odd number we need to have. Uh, I had that. Okay. So yeah, 3 and 5. You are right, not 4. I will correct myself. I was thinking something else. So thank you for correcting, Mir. Let me come to Nexus. I'll go into the charts and everything. If we have time in the ending, I'll explain you 3 and 5, all that data set, why, how it is working and everything. Now coming to the models, the hardware. In Cisco Nexus, we are using mainly 2 devices, that is 9500 and 9300. Okay. So when we talk about Nexus, device, okay. Can I move it? Okay. So when we talk about Nexus family, we have many different Nexus provide Nexus solution from Cisco. We have 9000 series, right? Which has 9500 and 9300. So these both can be used for ACI and NXOS. Okay. So what happens is that to run to for any Cisco ACI switches, spine or leaf, we need to have the ACI OS running on it. Okay, this is like specialized OS which we need to have so that they can run in the background, and they can provision the APIC servers, services and everything. We can have, so we have like switches, but we have 95330 and 9300 switches, 9000 series switches. We can configure them as an NXOS also. But if we configure as NXOS, they will not be able to, be used as a Cisco ACI fabric. Maybe you can configure an NXOS, Cisco ACI NXOS, and no, NXOS, a switch with an NXOS. Then we will have to do an L2 out and connect it to one of the leaf switches, but it will not be detected by APIC server, or it will not be provisioned in the ACI fabric. Okay, so for ACI we have very specialized switches, that is 9500 and 9300. Before that, we in Nexus devices, we had 7000 series, and we had 77,000 series, which we are called as 7Ks. Then we had 6,000 series in Nexus series. Then we had 5600 series. We had 5600 and 5500. Okay, let me just type. Then we had 4000 series. Okay, the 4000 series was very specialized series. It was for IBM Blade Center, so you'll not be able to see these usually in you'll not be able to see in work until unless it's a very specialized IBM Blade Center environment. Then we have same situation with 3000 series, which we use in high capacity environment. Then we have this is also very specialized one. Then we have 2000 let me just bring this up. Can I bring this up? Yep. We have 2000 series, which we called as fabric extenders, which we are using, to like on connecting to 5Ks, and we are extending them to connect our servers and other things. And then we have our 1000 V series virtual series, that is the lowest in the Nexus family. So for Cisco ACI, we are using 9500 and 9300. These are the main workhorse we can call as the Cisco fabric. Now 9500s are modular. They come in a modular configuration. 9300, we have 9300 switches are not modular. So in Leaf mostly we are using 9300, and in Spine we are using 9500. Let me highlight it. So these are mostly our Spine switches, okay? And in 9300 we have some models which we can use as a Spine, and also we have most of the models which we can like use in Leaf. So in Leaf switches you will see all the time 9300, you will never see 9500. So what are the offerings from the Cisco? Let me show you. Okay, so let me hide this. It's getting some problem. Oh, hide it open. Okay. So this first generation and second generation Cisco ACI leaf switches. Okay. So these PQ, how you will know that these are first generation. They are mostly like end of support right now. So coming to end of support, and mostly you will see if there is any deployment or new deployment, you will see these EX FX these switches. So how you will come to know that this is a first generation? It will generally start with PX or PQ. These switches are first generation switches. Now in second generation switches we have EX. Okay, this is like enhanced accountability. E stand for enhanced and X stand for accountability. So there's like minor changes, differences when Cisco comes up with any new iteration of new switches. E, when it stands for enhanced, it means that the endpoint, the switch is able to identify the endpoint of that destination on the device directly using the EPGs where it is. So that is called endpoint and accountability. This is an additional feature. So these are when you see 93180, it means that the device is having the capability of 180 gigs. So I'll show you let me see if I can share, and okay, let me show this one to you. So this is the family of 9000 hardware. Okay, so mostly you will be seeing these modules. So in 9000 we have 9500 series modular chassis. So modular, when we say modular, if you have worked with Nexus, you know that modular means that we can remove the module. Even in like normal Nexus switches, you have seen we have a different line cards, like M card, F card, F1 card, F2 card. So those card depends upon because those cards we can remove the modules, we can insert as per our requirement. We are calling it as modular, and the same thing applies to these 9500 switches also. We have the variation that comes is 4 slot, 8 slot, and 16 slot. Okay, and the modules it can support is 10 gig, 40 gig, 100 gig, 400 gig. And even right now we have like Cisco has come up with new modules, new technologies. So they are even providing 800 in that 800 GB module. So that's like a lot of bandwidth we are getting. So these are 9500 modules, 9500 switches, and you will always see them in the spine. Okay, no other device or no other endpoints will connect except for leaf. All the leaves will connect to these devices. This big one is the 16 slot. This one is 8 slot. This one is a 4 slot. And if we come to the background, are you able to see see this? It's a little bit small. Let me. Can you read it?
Yes, we can.
Okay, great. Great. So in 9500 platform components, these are like the front and the back. Okay, when we are talking about let's talk about the back first. So these are like power fan trays up to three per chassis. Then we have fabric modules. These are fabric modules. Okay, now what does for fabric module does is you will not connect any leaf or anything with fabric modules. The fabric modules a primary function is to give interconnectivity between these line cards. Okay, on the left side you will see that these are the line cards, 1 2 3 4. So depending upon the model, you can select how many modules you want, and you can swap that. So depending, these modules are connected here. So to for intercommunication between these modules, we are necessarily using these fabric modules. You can just imagine like this. It's like, it's like these are these are the modules. Okay, but these does not, how do they talk with each other? So there is this line, like this fabric module which comes from the back, and it connects all these line cards with each other so that they can communicate with each other, right? Nothing will connect, no cables or nothing will be connecting on the fabric module. This is just internal to that 9500 platform. Then we have two supervisor module, which is basically like our for management and for processing and everything. We are having supervisor modules. So up to two, in Nexus, if you have worked, we have standard way, like two soup models are there. So we can have up to two soup models connected here. Then these are the power supplies here connected here. So this is like the 9500 platform. Now coming to the 9300 platform. And okay, coming to the 93005, these are also called top of rack. Okay, now there, as I told you, in 9300 we have some modules, some models actually, which we can use as spine. And also we can there are 9300 will always be the leaf switch. Okay, we have these many interfaces, speed and everything. Let me bring 9300 model. Yeah, here it is. Let me show. Okay, so this is called 9300 ACI fixed leaf switches. Okay, now here we have 9336 FX2. As I told you, these are all new second generation EXFX, and this 9332 PQ, this is the first generation one, right? So these 9300 will not have SOAP module. Okay, that will be just for the 9500. These will have all like this normal. If you have seen a Catalyst Nexus Catalyst 9000 series switch, it will just look like that. Okay, depending upon the port, the number of ports, the bandwidth, there are different models which is provided by Cisco. We can check that by going on the website of Cisco, and checking out what are the modules that are required for as per our need, like the number of ports, the number of submodule, if it's a spine, if it's a Nexus. You can go download that data sheet, and you can decide that. So based on that, we can take the decision which one we want to implement, or which one we want to purchase. That's like a business requirement need. Now coming to Cisco and 95 and 93. So okay, so now I'm going to now I'm going to tell you about this APIC also. So APIC is basically a virtual system, right? APIC is not a physical device, right? It's a virtual machine that runs on a Cisco UCS blade. Okay, I'll just write it down. Cisco UCS blade, or let's say server. Okay, so what happens is that okay, so what happens is that we have Cisco provides us with Cisco UCS server, and this Cisco UCS server we have when we get the UCS server, there are two models in the UCS server, that is C220M3. This is like the first generation, and we have C220 sorry M4, which is like the second generation. Okay, here. So these are actual UCS server. If you have seen a server like any Dell server and any server in networking, so Cisco has provided with this UCS server, and on this UCS server using CIMC, you need to log into the server. You need to install the APIC virtual APIC software. You need to provision it on this UCS server. Once it comes up, then you need to configure the APIC. You need to configure the APIC server using the console first. You need to bring it into the network, and then you can work. You can then discover the fabric and everything. I am also going to show you in the lab about that discovery of how the discovery of the leaf and spine is done in ACI Fabric. So that will be in my lab today. We will go there. Now, this UCS server, basically we have, okay, so now coming to, I'll directly come to, the types of Cisco ACI Fabric. So there are different types. You will, whenever you are talking about Cisco ACI, you will hear a lot of, terminology going like multi-pod, multi-site. So it is a little bit confusing at first, but I'll tell you what it is and how it is, how that architecture is in Cisco ACI Fabric, right? So when we are talking about single pod, let's say we have a single data center. Let's just say you have a data center in Chicago, right? And you are creating a Cisco ACI Fabric. Now, what happens is that we have spine, we have leaf, we have APIC server. This is like what I have shown you. Leaf nodes are connected to spine, and APICs are connected to leaf nodes. This is like simple plain Cisco ACI Fabric, which is called as a single pod. Okay. Now coming to this is called stretched fabric. Okay. This is called stretched fabric. So let's just say, imagine like, you have a building in Chicago one, and what happened is that you just purchased a data center or building adjacent to it, and now you want to stretch your ACI Fabric to that second building, right? This is not always like advised by Cisco. There are multiple other solutions which I'll come which I will tell you in some time. But let's just say you want to stretch the fabric, right? So how you can do that? So that is called a stretched fabric in Cisco ACI terminology, wherein the only difference between single pod and the stretched fabric is that if you see this run I had given you one rule that in Cisco ACI all the leaves connect to spine, right? And or spines, they connect to each and every leaf. So it basically breaks that law. This is the only scenario where it breaks that law. Why? If you see, these are called transit nodes. So like any two or three leaf, you will dedicate them as a transit node on both the side, and you will connect you will connect those nodes with the adjacent spine, but you will not connect the rest of the leaf devices in your building one. You'll not connect rest of the devices to this DC2. You'll not see any connection. All the communication will happen via these transit nodes to these devices. So this is breaking the first law, and this is the only scenario where it can. So there are some complications related to this architecture, but if the need arise, definitely Cisco have you covered and they have given you a solution. Um, Let me. So the next the next solution is like, let's say, how do I delete? Okay. So next solution is, let's say I have next solution is, let's say I have I have data centers which are very far apart, very far away. We like they are, one is in Chicago, one is in Washington, and we want those two data centers to be connected to, they I want one single ACI fabric between running between those two. So it's a very long distance, and since this is all we are say going to send a lot of L2 traffic and everything, we need to extend this fabric, but also we need them to not have this stretched fabric kind of thing, because this they have some complication. So the solution, because we have right now many organizations which are we have many organizations which are basically using this multipod. Uh, okay, so multipod, this is multipod, and we have interpod network. Basically, to spine, there is this dedicated devices are connected, and through these devices, we are connected to DC2, and we are having this multipod setup. Now I'll just give you a very overbrief of how the devices are discovered in Cisco ACI Fabric. So in Cisco ACI Fabric, whenever we in Cisco ACI Fabric, all the devices are discovered using LLDP. So when a APIC is provisioned, pardon, sorry, when when any APIC is provisioned, okay, it will detect any leaf, any switch, and it will register them to its database using LLDP. So it will what APIC will do or Leaf will do is that it will send LLDP. It will receive LLDP, so it will know, okay, there is a device which is responding. Then there will be a request from the leaf. So we need to understand that this leaf is not connected to ACI Fabric. It will need an IP to come into the network to become a part of the ACI Fabric, right? So for that, it will need an IP. It will need an IP which we call as TEP IP. We have TEP IP. So it will need that IP, and it will get those IPs from APIC. So we are going to configure a pool of IPs on the APIC. So once any leaf or any Cisco ACI Fabric device comes, so APIC is going to assign those from that pool. So now the leaf will request a DHCP discover. So APIC will, uh, whenever a Cisco leaf or switch is provisioned in the fabric, it will APIC, you have to allow it, you have to register it on the APIC. Until unless you have allowed it, registered it, it will not be given any IP. It will just show you in the list of devices known, but it will not become a part of the fabric. Now, once APIC, we have clicked, a user here has clicked register, then it will offer the IPs, and then it will get the firmware. It will then check if the firmware is updated. If not, then the APIC will itself update the firmware of the leaf. Once everything is done, then all the policy configuration, everything will happen. Now I'll come directly to the lab and I'll show you. I'll show you how it is connected. Okay. Oh, you are you able to see my screen?
So I'm still seeing the APIC to leave discovery.
Okay, okay. Let me share you my new screen. Share screen, remote desktop. Here it goes. Okay. Let me know once you see my APIC screen.
Yeah, we are able to see.
Yeah, I can see your APIC screen now.
Okay, okay, great. One more thing, one more rule I would like to inform you. Like it's a recommendation, not a rule, but once in APIC, this is the version. You see, 6.07 iteration. This is the version. So usually when we are creating like we are implementing a new Cisco ACI fabric, we will for any version like 6.07 E, when we are pushing the version on the leaf switches or spine switches, it will always be starting with 1.6.0 something. Okay, so it's like Cisco's terminology. They if it's a version 6, so the leaf and spine switches version will be 16. Okay, 1.6. If it's let's say APIC 4.2, so the on leaf and switches, the firmware, the software will be uh, 14.1 or for 14.2 like that. Okay, so that's how like it is recommended because they are running in the same they are running in the same development cycle. That's how it is. Let me log into this. This is my APIC controller. So this APIC controller has now come up. We cannot show that the Cisco UCS fabric, UCS sorry server. So on the server we have installed the APIC software. We have configured the IPs and everything, and then it has come up, right? Because this is a virtual. This APIC is a virtual because when you are getting this lab access, it will be a virtual APIC. It will be already spun up for you. You just need to log into it. But in real scenario, we need it comes up. I'll show you how it is provisioned. Now when we are coming to APIC, it shows us the version here 6.0.0.6.0 and 7E. Now coming to we can do the start ACI fabric setup. So since this is a very new fabric, I can click here. Okay, it will give me a pop-up. It will open a new pop-up where I can see the many different options like fabric membership. So fabric membership is that when I talked about configure and register the leaf and spines detected by the ACI fabric. So ACI fabric detects any leaf and spine using LLDP. And when it detects, it will show me here and it will ask me that do I need to, can we allow this leaf or spine to connect to ACI fabric? So until unless I tell them you go, okay, register it, it will not allow it to be part of a Cisco ACI fabric. So that's a very good feature. Then this is management port. We have already configured it. That's why it's coming as a green tick. So basically it's for out of band management of the APIC and then we have VPC pairs, BGP, DNS, NTP, proxy. So these are multiple options. We will go in detail of each and every option in coming lectures. So let's just go ahead and do fabric membership. I click begin. So now here it comes. So right now that see here it is saying at least two leaves and two spines, one of each is required to proceed. Okay, so it is just telling me that you need a spine and leaf to register. That is what we are going to do right now. Now it has detected this switch model. Okay, this is like its serial number. It has given it, and it is saying that it is a leaf. Okay, now the Cisco ACI fabric is very smart enough. It automatically detects whenever doing that after any leaf or spine is connected into ACI fabric and the request comes to ACI fabric, it will know if it is a leaf or it is a spine. So let's say I have connected a 9500 line 9518 9518 model to the Cisco fabric. So this APIC will know that this is a spine. It will here it will come at as node role spine. Okay, if I connected like 93180 switch, it will here come as leaf. But right now, Cisco has also provided a new variation of Nexus devices, which ends with GX. Okay, what does the GX means is that here we will have to tell the ACIF this APIC controller has to tell that if it is going to be a leaf or a spine. So that's like a very advanced one which has been recently launched right now. But for now, it's for like rest of everything, it will just automatically detect itself. Now I'm going to take the action. I'm going to click register. So now you see it's coming. These are the options that is coming up. So node ID, I have to give it a node ID. So since it's leaf, let's say I name it as 201. Okay, I need to give it a name. I'll give this, since this is the first leaf, I will give it leaf 10, leaf 201. Okay. Now I can select pod also. So I had explained you the pod. They're like multi-pod scenario and other thing. For now, we will just leave it as it is, because just imagine if we have multi-pod, like we have a data center in Chicago, we have a data center in let's say Washington. So if someone connects a device in Washington and the APIC controller, I'm sitting in Chicago, I need to know where which device, which location that leaf or spine needs to be provisioned. So for that, we can select this pod. Then we have node type leaf and spine, which is automatically detected by it as leaf. And then I just need to click OK. Okay, now it's since my action has been completed, see, it has given its node ID. It's coming leaf. It's the name has changed. The name is coming. What the name I have given it. It can be anything as per your company policy. Then it's the status is coming pending. So I think it will. There are like the last stage when the whole process of discovery is completed, it will come as active. The status will show as active and it will be provisioned. So right now, I think there is it will take some time to come into active. Meanwhile, I'll just go back to overview and I'll go back to my API controller, since that is running in the background. Okay. And now this is how your APIC looks like. This is the brain of the Cisco ACI fabric. You see it is all GUI, and we have lots of options here. We have tenants, we have fabric, virtual networking. Under tenants, we have common infra management. So these are like VDC. If you have experience with VDC, virtual device context is in Nexus. Basically, it's like a virtual, it's like virtually different entity which is separate to each other. VDC1 is separate to VDC2. They'll not be communicating with each other until unless we allow them to. So there are different tenants that are these three different tenants are by default in the APIC. Whenever we are bringing up any APIC, you will see this one: common, infra, and management. So management, as you know, this is for the management of the APIC or the Cisco fabric. So when we are bringing up any devices, let's say Cisco leaf, spine, and everything, we want to manage them, right? We want them to have an IP address. We want them to share the details of the details of their connectivity to spine and with each other. So for that, we are using this tenant called management. Then we have infra. In infra, we are using mostly like for infrastructure, for common for infrastructure, like constructions, we are using this infra. And then we have a common. Common is for, like, let's say we have a common L3 out, L2 out. We have common a firewall or router that is being used between many VDCs, right? So we need to have a common that is shared between all the VDC. Okay, that, like, by default we can share this any objects, anything in the common tenant with other tenant that we have configured. So right now, since we are working to get the leaf and spine provision, I'll go to this fabric. So we need to go this fabric. This is where all the configuration related to the fabrics, all the leaf spine will be there. Now coming to fabric membership. So you can see here this is mentioning pod one, right? Because we have just one pod. This is not multi-pod, or this is like a single pod, simple ACI fabric. No complexity is there. So it's called pod one. Okay. If we had multiple pod, as I said, Washington and Chicago, let's say Washington is pod one and Chicago is pod two, we will see multiple of this. Okay. We will here see pod two, and then all these will be also visible under that. Now, once I expand that, I can see this leaf 201 node, right? Why, how I am able to see it? Because we had accepted this. Now coming to fabric membership. If I come to fabric membership, you see registered nodes. So now this node leaf 201 has registered itself using IP 10.0.120.64, right? So in ACI fabric, annotate. In ACI fabric, whenever we are bringing up the APIC, as I told you, we need to give pool. Okay, we need to give a pool of IP from where any new switch spine leaf, it will get it. The APIC will assign them those IPs. So that pool, as per Cisco recommendation, it should be the subnet mask of that uh, pool should be from /16 to /22. Okay, minimum this should be there. We should have a pool, or a subnet this big enough that we can assign to this fabric VTEP pool. So once this pool we have defined here, I have defined 10.0 10.0.0.0/16. It has automatically taken this IP and it has provisioned it with this IP. Now, as I told you, once this switch is provisioned in the fabric, the status changes to active, which we are seeing here, right? Now it's showing maintenance mode no, because we are not doing any maintenance. So in ACI, in actual production, what we do is that we club the odd and even number leaves. Let's say leaf 1, leaf 3, leaf 5. We will put them in one maintenance group, and we will put the odd one in a different maintenance group, so that once we have a change, we at a time, let's say we have 10, or let's say we have 40 leaf in our ACI fabric, and we want to upgrade them. So we can just group them, like we can make 4 group of 10 leaf each, and we can do in our maintenance window, we can do the maintenance, and there will be not be an impact, because since any server which is connected, they will be connected to 2 leaves, because every server will have 2 NIC cards, right? NIC 1, NIC 2. So we are choosing the odd one. So it and since this will be upgrading, there will be no impact, because this leaf 2 will be up, and it will be taking all the traffic automatically. All the traffic will be there. So that is the reason it is showing maintenance mode no. Delete it. Yeah. Okay, let me delete that. Clear products. Okay. So now the name has come, everything has come. Now I'll open this. Okay, this is this is generally showing the details. If I double click, it will show my leaf. Okay, the node is this, the node number that I have given 201, leaf name. This is the model 9396PX. So I just want you to tell me what generation is this? Anyone?
First generation.
Great.
Next
Yeah,
generation.
thank you. Thank you so much. So this is the first generation leaf switch, and now this has taken this IP, okay, /32. One more thing, all my leaves will be assigned with /32. Okay, they will have /32, some like single IP /32. Status is active, and everything is here. I can find more details about serial number and other this is like certificate. Okay, so once an APIC. So why this certificate? This is very interesting. Why this certificate in the leaf? Okay, well, like we have been managing server doing console, but we are doing SSH, right? But we are not like doing any certificates in there. But why here? So what's happening here? This is interesting. Let me little brief on you. So what is happening is that when an APIC talks to any leaf, let's say this is a leaf, okay, so once it discovers itself, let's say it's a discover, okay, I'll just hit discover. Once it is discovered, okay, now what will happen is that they will encrypt the all the communication between APIC and leaf, okay, so as to have a secure communication over this. Let's say this is a tunnel, okay, they create a secure tunnel using this certificate. So APIC, what will APIC do? APIC will share the certificate with leaves, and using the certificates, they will, that asymmetric encryption and then symmetric encryption, everything which happens with a certificate encryption, that will happen, and it will be a secure communication between leaf and APIC. So let's say even if someone drops a Wireshark or some other device here and captures this traffic, they will not be able to see anything. Everything will be encrypted. So that's why we are seeing the certificate details here. The certificate can be as APIC itself generated. You can also define that. Let me clear all ranks. Okay. So this coming to this other operations. Okay, I'll just quickly check on faults. So in ACI, in APIC, what happens is that most of the time in production environment, if your APIC is already provisioned, you will be working on faults. What does a fault mean? Fault is just like an incident, or something has not occurred right. So that alert will be given as faults. So you will be checking, like, today when you come into shift, okay, how is there any fault, how many faults are there, what I need to do. So when this was not registered, so it gave me a fault, it gave me a fault, or like an error, like an unregistered switch has been discovered but not registered yet. Great. Okay, so this is the timestamp. If I get this, okay, but now it is coming as green, so that means that this has been taken care. These are the different uh, you know color coded alert. If it is like, if what is the severity of this fault, so you will come to know. Even you will come to know all the history of related to this switch. Like, okay, it got discovered, but then it was soaking, it was, trying again and again. Every time it was dropping, we have severity. This is just like warning, because this is not a major fault. So this was warning. Once we accepted it, it was cleared. So you can see faults, events, audit log. So this is like a very detailed view you can get what happened with my leaf. So I'll just come on leaf. So once that leaf is discovered, you will see the leaf, all the logical constraints, all the policies, everything related to that leaf under this leaf one. Okay, you can see VRF context. You can see this sessions. Let me just open chassis. You see they are line modules. It is showing me line modules. What are the line modules? I can just, open it. I can check fan trays. I can see how many fan trays are there, what's the status and everything. So this is like related to everything related to chassis. Then I can come into interfaces. Now there are VPC interface, port channel, virtual port channel, routed interface, SVI interface, a lot of different MACsec tunnel interface. So a lot of different settings. I will go in the next lectures. I will explain you in detail what are these, how these are configured. So just to give you a simple overview, this is nothing but you just imagine it like you are logging into a normal switch. When you log into it, you go under that interface, right? You do configuration terminal, you go to interface, let's say Ethernet 1/1, then you do switch speed duplex, uh, uh, speed 100 or 1 gig or 10 gig, right? So in ACI Fabric, we do the same thing, but a little different because this is GUI. So whenever we are provisioning a new APIC, it takes a lot of a lot of effort to create those policies and everything. But once that is done, it becomes very easy. How then that policies will be available to you like this. You just need to drag and drop and you are okay. You don't need to even configure it, type the command speed 100, duplex, access VLAN, trunk VLAN, port channel, nothing. You don't need to type anything. You just need to drag and drop, and it will, or even select like a drop down menu, you can select it. And then what will happen is that it will automatically uh, provision those. Now coming, just because I have clicked on this tunnel one, I'll just tell you. You see, this is there is a tunnel already, which is built on the leaf. What is this tunnel? Because in ACI Fabric, all the leaves which are connected to each other, they will send the traffic or the data traffic over the tunnel. So just like a DMVPN, if you can imagine, in a DMVPN we have, let me just take this last topic and yeah. So this is the leaf, this is the leaf, this is the leaf, this is the spine, this is the spine, right? So these leaves will create a tunnel with leaf 2. Okay, these are all connected, right? Let's say these are all connected. Now what happens is that whenever any traffic goes, whenever these are provisioned, they come up, they will automatically, in a Cisco Fabric, they build a tunnel between each other. So tunnel one will basically have sorry, switch one will have, leaf one have a tunnel with leaf two. It will automatically create, and for that it will use its VTEP IP, the IP that we have, the APIC has provision, that will be very unique to each and every leaf, and that will be the source. So let's say this is this IP and this is like destination 10.0.0.1. So this switch is having an IP of 10.0.0.1. So there all the traffic will be sent over the tunnel, right? All the traffic will be sent over this tunnel. Uh, uh, Even like from leaf 1 to leaf 3, if there is any traffic that is going, first if it will have this tunnel created, and over that tunnel it will send that traffic from 1 to 3, for which we are using VTEP, or virtual tunnel endpoint, which we will explain more, which I'll explain more in the next lectures. And also we have like VXLAN is there, which is working in the background to send that L2 traffic over this routed network. So we have VXLAN, which is like encapsulating that layer 2 packet, L2 packet in the header, and that we are sending via VTEP to the destination. Essentially, we are sending L2 traffic over an L3 routed network. So L3 will be our underlay and L2 will be our overlay. So underlay and overlay. Uh, with that, I will now stop myself.
Quick question. What
Go
is the
ahead.
routing protocol between the spine and the
ISI.
leaves?
Yes, so the routing protocol that is running in the background is ISIS. So this is the protocol that is running and connecting all the leaf and spine. So that's how spine will know about all the endpoints that are connected to each and every leaf. For that, we are using ISIS in the background.
Okay, one more question. Do we have any active servers in the lab where we can test the connectivity, VXLAN from one endpoint to another endpoint?
So VXLAN, you will have a separate bonus lecture is there, as I read. So for VXLAN, that's a very different. But the beauty of ACI Fabric is that you don't need to pay more attention to VXLAN. You can know it for theoretical purpose, but APIC and ACI Fabric, what it does is that ACI has because VXLAN is an industry standard, right? So Cisco has customized it as per the ACI Fabric need, and due to that, it is all running in the background. We don't need to know what's happening with the VXLAN. We just need to know what my objective or goals is, and it will automatically the VXLAN will in the background automatically do its work. But we will definitely know, we will go into the deep dive how the VXLAN is working, why the VXLAN is working, and because we need to understand. But that is, I think, a different session. I think network journey that they will be able to tell when that is. And then VTAP, I will cover the VTAP, VTAP, VNI, how this traffic, how it is configured when a traffic comes to the switch, how it is being sent, how the decisions are being made, everything. I will go through each and every step with you. I'll tell you in the lab and in the theory also. So with that, I will hand this over to Network Journey, who is from Network Journey here. Hello, Network Journey. Sajid, you there?
Yeah, I'll be taking forward. So you can just complete if anyone has a Q&A.
Oh,
So
yeah, please, please. Anyone has any Q&A?
Yeah, I believe there is an SD-WAN also included in the course, right? So will it be taken by you or it's a different instructor?
Yes. So, so Network Journey, they will tell you. I am covering the Cisco ACI part, and for SD-WAN and the other part, we have available other trainers which will go into more details of SD-WAN with you.
Samir, how many classes will be there for SD-WAN and sorry, for ACI and SD-WAN?
Yes, so for ACI, there will be it will be around 30 hours of the schedule is for 30 hours of this training for ACI, in which we will cover the Cisco certification guideline of DCI. We will go as per that guideline. I think I have not shown you that, but yeah, so Cisco ACI certification is there. We will mostly cover that, all the topics in that, as per the Cisco certification guidelines. For SD-WAN network journey, the network journey team, they will tell you more about that.
And will there be lab access for us to practice ACI or?
Yeah, I think there is a lab access. I think network journey, Sajid can explain more on this part with you all. So I'm going to stop my share, and Sajid, up over to you now.
yeah, hello everyone. Good evening. Myself Sajid. I'm here to give you the details regarding this course and what all access and materials you'll be getting once you are going to enroll for this course. Can anyone just quickly confirm? Can you guys see my screen?
Yes. Yeah, it is visual.
Okay.
Yes.
Thank you. Thanks for confirmation. So quickly, let me start with my first slide. So as you can see here, so I have mentioned the course syllabus and course schedule. So here, this will be like SDN orchestration course, but we are going to cover here two-in-one combo course, like for ACI and SD-WAN, Cisco ACI and Cisco SD-WAN. Okay, and both will be taken by separate expert tutors. So ACI will be taken by trainer Samir, so who has expertise in towards DC ACI, and the Cisco SD-WAN will be taken by another expert trainer. Okay, and related to the class schedule, so this will be going to be a weekend batch, Saturday and Sunday. Okay, from 7 p.m. to 9 p.m. IST. Okay, so this will be going to be for 3 to 4 months of course duration. So like if you guys want to go one by one, so you can go that way as well. So if you want anyone want to complete it in earlier stage, so they can go for simultaneously as well. So we'll be having another batch for SD-WAN 2. So same time you can go for Cisco ACI and go for Cisco SD-WAN 2. Or else if you are good to go one by one, then you can go one by one too. Okay. And next, let me move towards the next slide. So here, as you can see, I have mentioned the details for what all course access you'll be getting once you are going to enroll. So as you can see here, so you'll be getting the lifetime recording access of your classes, which you'll be attending through the Zoom meeting. The sessions will be recording through the cloud, so that will be uploaded to the your web portal LMS from the backend, and that can be accessible for lifetime access. And the sessions will be uploaded in meantime of 1 hour or 2 hours. So once the session is completed, okay, so afterwards, like if in case if anyone missed out the session, so they can go for the recordings once the session is completed after 1 hour or 2 hours. Then you can catch up for tomorrow's class so that you can continue your pace with your studies. Okay. And secondly, we'll be providing you the remote lab access that can be accessible 24/7 unlimited. Whenever you want, you can access the labs, okay, which are present on our servers and cloud servers. So here one more point which I can tell you, like for ACI and for SD-WAN separately, you'll be getting 3 months of lab access that can be accessible 24/7 unlimited. Okay. And like we'll be providing you the dedicated materials like workbooks, PPTs, PDFs, step-by-step lab manuals, all the materials we will provide you that you can download and you can keep it with you as well. And the G drive access remains with you for lifetime. Let's say if in case if you missed out any of your materials, so which you have downloaded, in case got deleted or got corrupted, in any case, you can re-download the material once again using that G drive link. Once you get the access, that will remain for lifetime. Okay. And we'll be providing you the home lab setup too. Let's say if you have the good configuration of your system, then we'll be helping you to set up a home lab, so that once you are done with your remote lab access, further you can practice on your personal laptop, or it may be on your personal server. So some may will be having your personal servers, so we'll be helping you to set up a lab there as well. So for ACI and SD-WAN, so minimum you should have the requirement of your resource. Like for SD-WAN, there should be 64 GB of RAM, around 16 core of CPU, and 200 GB of 100 to 200 GB of storage available for SD-WAN. And for Cisco ACI, there should be like around 16 to 32 core of CPU, and around 128 GB of RAM, and 2 to 300 GB of storage sufficient for your ACI lab practicing. Okay. And we'll be providing you the 24/7 backend support from our team. Like let's say if you are facing any issues, any queries regarding to the course, or regarding to the portal, or regarding to the lab, anything it may be, you can just reach us out through our support DL. So one of our team member will connect with you and we will resolve your issues accordingly in meantime. Okay. So let me move towards the next slide. So regarding to the pricing part.
Hello.
So,
Sorry, I have one question, please.
yeah.
Regarding to the remote lab access, okay, it will be on the cloud, correct?
Sorry, can you come again? Lost you.
I mean, we can participate in lab using the cloud, which is remotely, okay?
Yeah, you
Going
mean
to-
to ask like we are providing you the access from our side, right? Remote lab
Yes,
access.
yeah. So this access will be within the course duration or after the course?
Like let's say once you are going to start with this course from next week. So from next week for ACI, you'll be getting the 3 months of lab access there. Like course will get completed in 2 months of duration. So additional 1 month of access will be getting to practice.
Okay. Okay, thank you.
Yeah.
Sajid, can you help this labs build in cloud like AWS or Azure?
Sorry, lost you. I think some network problem or something. Can you please come again?
Yeah. So you mentioned setting up the home lab. Can you assist in building the lab in the cloud like in AWS?
Yeah, if you have enough resource and enough storage and RAM, if you are available with your cloud user account, So we'll be helping out to deploy. But thing is like we need to upload the files or require things on your cloud account. So from there easily we can do the setup. Like if you have some virtualization there present there, so easily we can do the setup.
Okay, thank you.